You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Fast feedback represents the ability to shorten the distance between an idea and evidence. Design thinking and lean startup are two approaches that, when used together, reinforce this capability. Design thinking emphasizes empathic discovery seeking to understand people's real experiences, frustrations, and needs, while lean startup emphasizes disciplined experimentation that tests assumptions quickly. Together they connect curiosity to data, ensuring that exploration does not drift endlessly and that testing is grounded in human reality. This combination allows teams to avoid the trap of building elegant solutions to misunderstood problems or running clever experiments without context. Instead, teams empathize with users, frame the problem, generate options, and then validate them with minimal investment. Fast feedback makes learning continuous rather than episodic, converting uncertainty into insight before large investments are made. In time-constrained, high-stakes environments, this discipline is what turns ideas into progress, rather than into risk. Empathy work is the foundation of meaningful discovery. It grounds exploration in the lived reality of users by observing, conversing, and walking through their actual experiences. Specifications and requirements documents often miss nuances, like the workarounds people invent or the subtle frustrations that erode trust. For example, watching customers navigate a checkout flow may reveal that they abandon not because of technical errors, but because they distrust the lack of visible confirmation. Empathy uncovers constraints and desires that numbers alone cannot. It creates context for ideas, ensuring solutions are anchored in human need. Without empathy work, innovation risks becoming detached from reality, solving theoretical problems while missing actual ones. Fast feedback begins with listening, because speed is useless if it runs in the wrong direction. Empathy slows the start in order to accelerate learning downstream. Problem framing translates raw observation into a clear point of view that guides exploration. A well-framed problem articulates who the user is, what job they need done, and why current options fall short. For instance, a team might frame the problem as, busy parents need a way to prepare healthy meals quickly because current apps focus only on recipes, not shopping logistics. Such clarity directs ideation and testing, preventing the drift of chasing solutions without shared focus. Problem framing also provides alignment across roles: design, engineering, business, so that each experiment ties back to the same challenge. Without framing, teams risk spreading effort across disconnected ideas, diluting insight. Fast feedback depends on precision. You cannot validate assumptions if the problem is undefined. A good frame does not restrict creativity. It channels it toward relevant and testable outcomes. Ideation practices expand the solution space before narrowing it. The temptation is to seize the first plausible idea and rush it into testing, but this often produces comparisons between weak options. Structured ideation, such as brainstorming, sketching, or design studios, generates multiple possibilities, raising the chance that experiments test genuinely good alternatives. For example, in exploring ways to reduce customer wait times, one team might consider improved scheduling, predictive notifications, and real-time chat support. Testing across these expands understanding of what users value most. Ideation ensures that feedback loops are not wasted validating mediocrity. The point is not to polish every option, but to create a rich pool from which to draw experiments. By resisting premature convergence, ideation increases the quality of fast feedback and the likelihood that what endures is worth scaling. Prototyping as a learning tool emphasizes speed and purpose over polish. A prototype is not an early version of the product, but a deliberate artifact built to answer a question. This could be as simple as a sketch, a clickable mock-up, or a code stub, depending on what needs testing. For example, if the question is about navigation clarity, a paper sketch may suffice. If the question is about integration feasibility, a stub might be required. The danger is overinvestment, spending weeks perfecting a prototype only to learn something that could have been discovered in hours. Fast feedback culture treats prototypes as disposable instruments of learning, not precious artifacts. Each prototype is chosen for its ability to validate or disprove an assumption quickly. By lowering the cost of iteration, teams unlock the courage to explore widely, knowing that learning, not polish, is the goal. Test design brings rigor to experiments by defining success signals, failure thresholds, and observation methods before running them. Without clear criteria, teams risk interpreting results to fit their preferences, delaying learning. For example, a test of a new sign-up flow might specify success equals 20% increase in completion rates over baseline within 2 weeks. Thresholds clarify when to pivot, persevere, or pause. Observation methods such as direct recording, surveys, or telemetry ensure data is reliable. Test design prevents ambiguity from clouding decisions. It forces teams to articulate what they hope to learn and how they will know if reality confirms or rejects their assumption. Fast feedback requires not only speed but also integrity. Clear test design ensures that learning is trustworthy, actionable, and defensible, even when it challenges initial hopes. The build, measure, learn loop, central to lean startup, reframes delivery as a sequence of experiments. Each iteration is designed to answer a specific business or user question. The team builds only enough to test, measures results with defined signals, and then learns what the data says. This cycle repeats, accelerating insight and reducing wasted effort. For example, instead of building a full recommendation engine, a team might manually curate suggestions for a small group, measuring engagement. If the hypothesis is confirmed, automation follows. If not, effort is saved. Build, measure, learn ensures that activity is always tied to learning. Without it, teams risk building features endlessly without ever testing whether they matter. The loop embodies fast feedback, short, purposeful cycles that transform uncertainty into evidence. The minimum viable product, or MVP, applies this principle at scale by delivering the smallest coherent experience that validates key assumptions. An MVP is not a half-built product but a focused experiment packaged as a usable slice. For example, a ride-sharing service might start with a hotline and manual driver coordination to test demand before building an app. The goal is not to ship everything but to prove or disprove critical assumptions quickly. MVPs reduce risk by demanding clarity. What must be true for this idea to succeed, and what is the least costly way to test it? Without this discipline, organizations overcommit to full feature builds that may flop. MVPs embody the spirit of fast feedback: deliver enough to learn, then decide whether to invest further. Instrumentation and telemetry planning ensures that the data needed for learning is captured reliably and ethically from the start. Events, funnels, and cohort tracking must be designed before experiments launch, not bolted on afterward. For example, testing a new checkout flow requires logging start and completion rates, abandonment points, and error messages. Telemetry provides the evidence for decision-making, but it must respect privacy and compliance obligations. Fast feedback fails if data is incomplete, delayed, or untrustworthy. Instrumentation ensures that every cycle produces actionable evidence rather than ambiguous signals. Planning also avoids wasted cycles. Without telemetry, teams may end a time box with opinions instead of facts. Proper instrumentation transforms each experiment into a measurable investment in learning. Cohort and segmentation analysis prevents averages from hiding where value concentrates or harm emerges. Different groups may experience the same change differently. For example, a new feature may boost engagement for new users while confusing long-time users. Without segmentation, the average may suggest mild success, masking the harm to an important cohort. Segmenting by demographics, behavior, or context reveals where value is real and where risks lurk. Fast feedback requires precision, not only whether something works, but for whom it works. This analysis sharpens decisions, ensuring that scaling benefits the right audiences while avoiding unintended harm. Cohort thinking moves experimentation from broad generalization into targeted insight, increasing confidence that what is validated truly aligns with user diversity and business priorities. Learning metrics shift focus from volume of tests to quality of insight. Useful measures include signal clarity, time to validated learning, and decision velocity. For instance, tracking how long it takes from idea to evidence highlights whether feedback loops are fast or sluggish. Decision velocity measures whether insights are actually acted upon rather than sitting idle. Without these metrics, organizations may mistake activity for progress, running numerous tests but failing to learn. Fast feedback culture values the speed of turning questions into answers and answers into action. By measuring learning itself, teams keep focus on their true purpose, accelerating knowledge that drives better outcomes. This perspective transforms experimentation from a side activity into the core engine of strategy and execution. Pivot, persevere, or pause criteria ensure that decisions follow evidence rather than inertia. A pivot means changing direction based on disconfirmed assumptions. Perseverance means continuing because evidence is promising, and pause means stopping until more data is available. For example, a team might pivot from a mobile-first design to a web-first approach if tests show mobile users are not the target segment. Criteria make these choices explicit, preventing drift where teams continue investing in ambiguous or failing ideas. Without such discipline, experiments produce data but decisions stall. Fast feedback requires not just learning but action. Pivot, persevere, pause criteria transform results into choices, keeping momentum and ensuring that cycles drive adaptation rather than stasis. Ethics and safety guardrails protect users and organizations from the risks of rapid experimentation. Speed cannot justify harm. Guardrails require that tests respect privacy, avoid manipulation, and comply with safety and regulatory standards. For example, testing new pricing models must ensure transparency to avoid misleading users. Ethical boundaries build trust, ensuring that fast feedback accelerates learning without externalizing risk onto customers or brand reputation. Without guardrails, short-term gains may trigger long-term damage. Responsible experimentation proves that speed and safety can coexist. A culture of fast feedback acknowledges that the goal is not just to learn quickly but to learn responsibly, protecting people while improving outcomes. Fast feedback requires coordinated roles that align product, design, engineering, data, and risk expertise. Each role contributes essential perspective. Product defines hypotheses, design crafts prototypes, engineering builds stubs, data ensures measurement, and risk partners guard compliance. When aligned, these roles create end-to-end learning without handoff delays. For example, a test may move from prototype to deployment within days because all disciplines contribute from the start. Without coordination, feedback slows as experiments are queued between silos. Fast feedback thrives on collaboration, where diverse skills converge on a shared goal: rapid, reliable learning. Coordination is not optional. It is the mechanism that compresses cycles and ensures that insights arrive quickly enough to guide strategy and design. Anti-patterns warn against practices that undermine fast feedback. Vanity tests are run without decision stakes, producing data that no one uses. Overinvestment in prototypes wastes time perfecting artifacts that should have been quick tests. Data hoarding delays learning by collecting endless metrics without analyzing or acting. For example, running A/B tests for months without clear criteria or decisions produces noise, not knowledge. These anti-patterns waste cycles and create the illusion of progress. Recognizing and avoiding them preserves the integrity of fast feedback culture. The goal is not to experiment for its own sake, but to experiment to decide. By staying disciplined, teams avoid the trap of speed without impact, ensuring that every test feeds into clearer, faster decisions. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Selecting the right research method is essential for efficient learning. Different questions require different tools. Contextual inquiry uncovers how users behave in their natural environment. Usability testing examines how well a prototype supports specific tasks. And concierge experiments test viability by simulating functionality with manual effort. Each method balances depth, cost, and risk of bias. For example, when the question is about desirability, observing users in context may reveal hidden needs better than surveys. When the question is about feasibility, a small technical spike might provide clearer answers. Without alignment between question and method, experiments waste time or mislead. Fast feedback depends on choosing methods that provide reliable insight quickly. Teams that match techniques to the decision at hand avoid both overbuilding and underlearning, accelerating their ability to pivot or persevere based on evidence. Assumption mapping provides structure by making implicit beliefs explicit and prioritizing them by risk. Assumptions are grouped into categories of desirability, feasibility, and viability. For example, desirability might assume that customers want real-time updates, feasibility might assume that the system can scale, and viability might assume that pricing covers costs. Once mapped, assumptions are ranked by their importance and uncertainty. High-risk assumptions are tested first, preventing teams from building around fragile foundations. Without mapping, risky assumptions often remain invisible until late failure. By visualizing and ranking assumptions, teams focus experiments where they matter most. Fast feedback thrives on targeting uncertainty deliberately. Mapping transforms experimentation from scattershot activity into a disciplined campaign against the most dangerous unknowns. An experiment backlog maintains a steady flow of learning by treating tests like work items with owners, priorities, and cadence. Just as delivery backlogs structure feature development, experiment backlogs ensure discovery is continuous. For example, a team may plan 3 small tests each sprint, each designed to validate a different assumption. Assigning clear ownership prevents experiments from being abandoned mid-cycle, while cadence ensures learning keeps pace with delivery. Without this backlog, experimentation becomes sporadic, producing gaps in evidence. A visible, prioritized backlog signals that learning is not a side task, but a core responsibility. This rhythm of experiments accelerates feedback loops and keeps decision-making grounded in evidence. By scheduling discovery deliberately, organizations integrate it seamlessly with execution, ensuring neither lags behind. A/B testing and multivariate approaches are powerful tools for structured comparisons. A/B testing exposes 2 groups to different versions of a feature, while multivariate testing examines multiple elements simultaneously. For example, an e-commerce site might test 2 checkout flows to measure which increases conversion. Proper execution requires attention to sample size, duration, and avoiding peaking bias-ending tests early, when results look promising but lack statistical reliability. Done correctly, these methods provide high-confidence evidence. Done poorly, they mislead with false positives or negatives. Fast feedback requires discipline as well as speed. Controlled testing ensures that decisions rest on signal, not noise, turning user behavior into clear evidence about what works. This rigor makes A/B and multivariate tests cornerstones of lean startup practice. Qualitative synthesis methods complement numeric results by interpreting patterns in user observations. Affinity grouping organizes notes or quotes into themes, while thematic analysis uncovers recurring pain points or opportunities. For example, multiple usability sessions might reveal different wording preferences that cluster around clarity needs. These qualitative insights explain why metrics shift, adding depth to numbers. Without synthesis, teams risk drowning in anecdotes or misinterpreting isolated stories. By grouping and analyzing systematically, teams create balanced perspectives. Numbers show what is happening. Stories reveal why. Together, They produce richer learning. Fast feedback culture thrives when teams can interpret both quantitative and qualitative signals, creating insights that are actionable, empathetic, and evidence-based. Synthesis ensures that user voices shape not only design but also strategy. Integration with agile cadence embeds discovery directly into refinement and planning. Findings from experiments should flow immediately into backlog updates, story slicing, and prioritization. For example, if a test reveals that users value speed over customization, refinement may pivot toward performance features in the next sprint. Without integration, discovery risks being sidelined, with evidence piling up in reports rather than guiding delivery. Embedding findings ensures learning shapes execution continuously. This prevents the false separation of research phases and delivery phases. Fast feedback depends on making discovery part of the same rhythm as development, with insights flowing directly into the work pipeline. Integration accelerates adaptation by turning evidence into action in real time. Feature toggles and staged rollouts allow safe exposure of experiments to limited cohorts. Toggles decouple deployment from release, letting teams ship code but selectively activate it. Staged rollouts gradually expand exposure, starting with small user groups. For example, a toggle might expose a new feature to 5% of users, expanding as confidence grows. These practices make experimentation safer because if issues arise, exposure can be halted or rolled back. Without such mechanisms, experiments risk destabilizing production or alienating users. Fast feedback requires controlled risk, the ability to test in real conditions without jeopardizing the system. Toggles and rollouts provide that control, making experimentation practical in complex, high-stakes environments. They ensure that learning and reliability advance together. Operational readiness for experiments ensures that even trials are monitored and reversible. This means setting up alerting, logging, and rollback paths before exposing users to new experiences. For example, an experimental recommendation algorithm should be monitored for latency and user drop-off, with clear rollback options if performance degrades. Readiness prevents experiments from creating instability in the pursuit of learning. Without it, teams risk turning tests into unplanned outages. Fast feedback must protect both speed and safety. Operational readiness demonstrates maturity. Experiments are designed not only to learn quickly, but also to fail gracefully. This discipline preserves stakeholder trust, showing that innovation and reliability are not at odds. Decision forums keep momentum by reviewing experiment outcomes regularly. These forums document rationale, uncertainties, and follow-up actions, preventing data from languishing unused. For example, a weekly review might examine 3 completed experiments, decide on pivots or next steps, and update the backlog accordingly. Decision forums also build transparency by showing how evidence shapes direction. Without them, teams risk running many experiments but delaying decisions, undermining fast feedback. Forums transform data into action with discipline. They ensure that learning is not only rapid but also applied, maintaining organizational agility. By institutionalizing decision-making rhythms, forums protect against drift and ensure feedback loops remain closed rather than open-ended. Scaling validated ideas transitions them from MVPs to hardened features. Once evidence shows an idea works, investment shifts to strengthening quality, performance, and operability. For example, a concierge experiment that validated demand for delivery scheduling might evolve into a fully automated system with monitoring and resilience. Scaling is not about adding features blindly, but about prioritizing enhancements based on observed usage and value. Without disciplined scaling, teams risk overbuilding or ignoring proven opportunities. Fast feedback thrives when validated ideas are given the resources to mature responsibly. Scaling bridges the gap between discovery and delivery, ensuring that experiments translate into enduring outcomes. It transforms quick wins into sustainable capabilities. Portfolio learning views aggregate insights across products, guiding strategic bets with evidence rather than anecdote. For example, if experiments across several teams show that real-time notifications drive engagement, portfolio leaders may invest in shared platforms to support this capability. Aggregated learning ensures that insights compound rather than remain isolated. Without this perspective, organizations may duplicate experiments or fail to spot systemic opportunities. Fast feedback gains strategic power when individual experiments feed into collective wisdom. Portfolio-level synthesis turns local learning into enterprise advantage, aligning resources with proven patterns. This builds an organizational culture where evidence, not hierarchy, directs big bets. Knowledge repositories capture hypotheses, designs, results, and decisions in searchable form, ensuring learning is reusable. For example, a repository might store failed experiments alongside successful ones, preventing teams from repeating costly dead ends. Without repositories, insights are lost in presentations or personal memory, wasting organizational investment in learning. By preserving context and rationale, repositories provide continuity across time and teams. Fast feedback depends on compounding insight, not relearning. A well-maintained repository transforms experimentation from isolated activity into a shared knowledge base. This supports both speed and consistency, because new teams build on prior evidence rather than starting from scratch. Remote-friendly fast feedback practices ensure distributed teams participate fully in discovery and testing. Shared tools allow prototypes to be explored online. Recorded sessions enable observation across time zones, and asynchronous analysis supports diverse participation. For example, remote testers might record usability sessions, with teams conducting thematic analysis later. Without adaptation, distance becomes a barrier to involvement, limiting learning to co-located participants. Remote practices level the playing field, making discovery inclusive. This inclusivity strengthens insight by drawing on diverse perspectives. Fast feedback culture thrives when all contributors, regardless of location, have equal ability to prototype, observe, and analyze. Remote adaptation ensures speed and inclusivity coexist, preserving learning integrity. Success signals confirm whether fast feedback practices are compounding value. Signs include shorter time to validated learning, higher hit rates on shipped features, and reduced rework from misaligned assumptions. For example, if the percentage of experiments leading to adopted features rises, it shows learning quality is improving. If cycle time from idea to decision shrinks, the feedback loop is accelerating. Without such signals, organizations may not know whether they are learning faster or simply experimenting more. Fast feedback proves itself in outcomes: better bets, quicker pivots, and fewer costly mistakes. Success is measured not in the number of tests, but in the quality of decisions and the speed of adaptation. These signals demonstrate that empathic discovery and disciplined experimentation are compounding into strategic advantage. In conclusion, fast feedback integrates design thinking's empathic discovery with lean startups' disciplined experimentation. Empathy grounds exploration in human reality, problem framing directs focus, and prototyping provides disposable tools for learning. Lean startup practices like build, measure, learn, and MVPs ensure delivery becomes a sequence of purposeful tests. Instrumentation, segmentation, and learning metrics provide rigor, while pivots, ethics guardrails, and decision forums translate evidence into action. Scaling validated ideas and aggregating portfolio insights ensure learning compounds across time and teams. Remote practices extend inclusion, and success signals confirm acceleration of outcomes. On the exam, candidates will be tested on whether they can connect discovery and experimentation into coherent feedback systems. In practice, fast feedback is the engine that turns ideas into reliable outcomes quickly, preserving both speed and responsibility. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.